All right, so just going to look at an interesting property of integration. And basically, you're just going to consider the case where you've got some function and then you move it left or right. So we're doing a horizontal translation. So this is what the property says. It says if you take the integral from a to b of f of x dx, that's equal to the integral from a plus h to b plus h of f of x minus h. So it's a bit abstract at the moment, but if we think about a graph, I've just picked a function here in purple, f of x, that we're going to call x squared. So this is just the graph of x squared. Okay, f of x minus h would represent a horizontal shift. So if h was 2, for example, we'd be moving it to the right, let's say 2. So this purple line now represents f of x minus 2. So it's a shift to the right by 2. And then what we want to do is, all right, we'll talk about the areas underneath. So let's take if we put h back to 0 for now, let's just consider f of x between the points. Let's go between 1 and 2. Now let's do 1 and 3. We'll do 1 and 2. So we're finding the area underneath x squared between 1 and 2. Okay, and then what we're saying is if we take a horizontal shift, so if I shift the whole thing, let's say 3 to the right, we can see that the area is maintained. And you can see that the bounds have now become, well, the lower bound was initially a, which was 1, and the upper bound was 2, but then we've shifted everything to the right by 3. So 1 becomes 4 and 2 becomes 5. But the whole function's also moved to the right. So we can see that the areas are maintained. So hopefully you can see why the integral from a to b of f of x dx equals the integral from a plus h to b plus h of f of x minus h. You just sort of shifted everything to the right. So the area is maintained. Yeah, hopefully that's helpful.